Hello, Internet peoples. My name is Guy Royce, and today we're going to continue on with our quest to find Bigfoot restfully. We're going to take our service that we built in part 1 and expand on it to use RediSearch to create interesting queries that allow us to search for Bigfoot in states, within counties, and even within latitude and longitude georadius type stuff. So stick around and watch how we do it. With me, Guy Royce.
And in the corner.
Let's do something a little more interesting. Let's go ahead and, do we want to do the text search first or the county state? Let's do county state first. Now I've got a little bit of cheater code over here on the right, and I'm going to copy and paste that because this is a little bit boilerplate. So let me grab my cheater code here. You can tell when I'm looking to the right, I'm looking at my cheater code, right? So here we're going to do sightings for state. And then you specify the state name. So this is a little URL that says sightings for state Ohio or sightings for state West Virginia or whatever. And then we'll add to the sightings data, we'll add a find by state, and we'll put request parameter states, and we'll do a find by county and state. I don't see a need to do county alone because there's lots of counties that have duplicate names across the United States. And so they always need to be paired with a state. So we got county and state here as well. I'm going to go ahead and we'll just leave those in place. Let's implement find by state and find by county state. That is what I call those, right? Yeah, find by state. We'll call this state. And we're going to do this a little differently because, well, we have to use RediSearch, and RediSearch is a little different. And so we need to say this dot connection dot call, not that, call ft dot search. And then we need to give it, look at my cheater code here, an index name. That index name is going to be, we'll call it sightings index. We need to give it a query, and that is going to be, we'll backtick that because we're going to interpolate that. That's going to be at and then the field name that we want to search by. Now we haven't created our index yet, so this isn't going to work, but we know that the field name we want to search by is called state, and then we want to specify the state. And now we are going to define this as a tag, which means it's a discrete value as opposed to like a text searchable field. So it's like we want to look for the state of Ohio, not things that contain Ohio. And so otherwise, if we did like Carolina, we would get North and South Carolina back, and we just want to say states as like an enumeration. So we're going to put that in curly braces, and that's how we tell RediSearch that looking by state is a discrete value, that it's a tag. So that's our query. And then we also need to specify a limit because it can return multiple things. You can get a really big query. We want to put a reasonable limit on it. And so this is actually paginated. And so we're going to say, give us everything from position 0 in the results and the first 100. So that means that we can get at most 100 results from this search. So there we go. That will return a thing. However, it's not going to work yet. We need to build our index. So to build our index, we have to use an init, and this is another call. And we're going to keep building and rebuilding this index for each time we run this, because we're going to be running this a lot during development. So I'm going to put code in there that looks for all the indices, deletes the one that we have made up, and then recreates it each time we load sightings data. In production, this would not be a great idea. Because you would not want to tear down and rebuild your indexes all the time. You would want to write something a little smarter. And if you had a lot of data, you wouldn't want to do it even whenever the application started, because that could take a while. We have 4,586 Bigfoot sightings. This isn't a huge deal, right? And we're doing some development work here. So this is a convenient way for us to handle this. And so let's get the indices out of there and say list by saying indices equals await this dot call, and we're going to call ft dot underscore list, which will give us a list of all the indices. Then we're going to say if the indices includes that's sightings : index. So the fact that I want to copy this tells me I need a constant. I'm just going to call it index. So includes index. Then we're going to do a thing. We'll put the index down here too. So so get our indices. If the indices include the index, then we want to delete that index or drop it. This dot connection dot call. Just realized I missed a connection up here. Connection. If I could type today, that'd be great. This dot connection dot call, and we're going to pass in ft dot drop index, and then index. And now we're going to create our index. So if there is an index, this gets a list of all the indexes. If it's empty, then we don't do anything. If our index is in there, we drop it, and then we create the one that we want for this run. So we're going to say await, and this is also we want to await this as well. Await this dot connection dot call ft dot create, and then we need to give it the index name. And I'm going to go ahead and put this on the next line because we got a lot of stuff that is going to end up in here. Give it the index name. We want to say, what are we indexing on? We're indexing on hashes, which is the only option right now. But as RediSearch 2.0 grows and matures, we will add new types. But right now, it's just going to look for hashes. We're going to say, look for hashes that have the prefix in their key of, not the number 1. We only want one prefix. This is really prefixes, not prefix. But we want one prefix, and we want them to start with citing. So this will create an index of hashes that are prefixed with the word citing : so that'd be all of our Bigfoot sightings. If we had another thing we wanted to do, we could put a 2 there and say, other things like that. But we don't have that scenario. And then we tell it the schema of our data. And so for our schema here, we are looking for state and county. So let's add county and state in here first. So we'll put county, just because counties tend to come first, I guess. And we tell it that the county field is a tag that makes it that discrete value, that enumeration kind of thing. And then we give it a state, and that is also a tag. And that builds an index which will allow us to search by county and state. We're going to expand this as we go on. So find by state, at state, limits 0 through 100. I'm going to go ahead and do find by county and state. That is what I called it, right? Find by county state. Yes. And that's going to take the county and the state. And this will just be at county. And it's exactly the same syntax, and they're just space delimited. And now that we've done this, it immediately strikes me that I have some duplicated code here. So I'm going to create a private function. We'll say it's private, but it's not really private. Just called find. And it's just going to take a query. And it's just going to do, well, this. And instead of this string being built up, we'll just pass in query, because this is duplicated otherwise. And then in here, we'll say return, await, find, this dot find, that's correct. And then we'll just build up our little query there. And now we've got a nice tight little snippet of code here, which I'm just going to copy pasta down to here. that. And do that. Okay, I've written a lot of code without running anything that assures me that this might work. So let's kill the server and start it back up. Okay, it's running. That's a good sign, right? Let's make sure that our citing still works. It does. Let's go for sightings in the state of Ohio, where I'm at. And that blew up, which means I've got a mistake here. Sightings data is not defined. So I have let sightings data. This singular plural thing is going to sink me, man. I need to pick one way to type this and be done with it. So we'll call it sighting data. And here we got sighting data and sighting data. There we go. Okay, citing state Ohio. I think it's probably that. That'd be sightings state Ohio. There we go. That's all the ones for Ohio. If we want to get, yeah, there's 257 of them. This is just the raw Redis response coming back. So you see here, Redis returns an array with the number and then key value, key value, key value. And then the value is an array itself and it's key value, key value, key value, key value. That's not a very happy way to return this data, but that's what Redis likes to do by default, which works fine from the CLI. We're going to improve on that for our client. We don't want to hand this back to our end users, but let's make sure that our plumbing is working. Let's make sure that we can do citing 1, 2, 3, 4 again. That works. Make sure we can do sightings by county and state. So county, we'll go with Athens County and state of Ohio, prime Bigfoot country down there. So we've got 5 sightings near Athens, Ohio. Good stuff. Okay, let's transform this a little bit to make it a little friendlier for humans to read and or our applications to read. And I've got a little bit of cheater code here, but I'm going to type it up because it's kind of interesting. So I'm going to get the results of calling search here, and I'm not going to return them. Instead, what I'm going to do is I'm going to destructure them. I'm going to say let the count, that'd be the number that it finds, and the found keys and sightings. So what this is going to do is this is going to get the first value of that array that's being returned and shove it into the variable count. And this is going to take the rest of the array and shove it into a new array called found keys and sightings. And so I'm pulling apart the count and the found keys and sightings. And then I actually don't want the key names. I don't want to expose the key names to the end user. They just know about IDs. Key names are a Redis thing, not a REST thing. So we want to pull that out. So we're going to say let found sightings, just the sightings, just the arrays containing the sightings data, equal found keys and sightings. And we're going to do a filter on that. And we're going to get the entry, which we don't actually care about. And we're going to get the index, which we do. And we're going to say if the index modulus 2 is 0. So we don't care about the key. That's on the odds. The values are on the evens. So this is saying if the index of this key, found key and citing is even, then return it. So we're just cutting out all the keys. Kind of neat. Now we want to get the actual sightings. And this is where it gets kind of hairy. So let sightings, which are going to be objects, equal found sightings. And we're going to map each found sighting, which is a citing array, to a thing. And then that citing array is, again, made up of keys and values in the same way. But this time we want the keys and values. So we'll say let keys equal citing array dot filter, again, underscore, and index. And we're going to do the same even odd thing, except we're going to keep them both. So here we're going to say index modulus 2 is not equal to 0. And I missed a parenthesis in here. There we go. That will get us the keys out of that key value array. And then we can get the values using, well, on the evens. Let's say that equals 0. So now we got the keys and the values in two separate parallel arrays. So now we need to build an object out of those. I'm going to do reduce. So we're going to return keys.reduce. And in here, we're going to get the citing. This is the previous value that's passed, and this is the accumulator of the reduction. We're going to get the key. That'd be the key name. We're reducing our keys, so it's got a key name of, like, you know, location or state or county or whatever. Excuse me. And we're going to look at the index. And then we're going to give it a little arrow function to do the reduction. It also needs an initial value. That's going to be empty object. So we're going to add keys to this object and then keep returning it. So here we can say citing of the key. So this is the same thing as saying like citing.location or citing.state is equal to values of index. So this is mapping that over. And then here we can return the citing. And so the citing was passed in. We've added a thing to it, a key and a value to it, a property, and then we return it. And then we keep adding to it until we're done. And so that reduces this keys and values arrays into a single object. So that will give us our citings. And so now we have to actually return something. So let's return an object that has the count. That'd be the number of things were found above the limit. We limit it to 100, but if we find 500 things, then it'll say 500. And the citings. That's a lot of code. It's kind of complicated, but it is the most complicated code we're going to see today. So we got it up and running. Let's see if this still works. It does not. A citing array.filter is not a function on line 42. So that's citing array.
"75 years later."
Ah, that one's failing because I named it index name in my cheater code. Okay. Now we're getting the HTTPS problem. There we go. So this still works, but it is now returning a count, and our sightings here is an array. We got 5 sightings in Athens, Ohio. Right? I am reporting a second incident which occurred in the same location as report 3533 from 1998. We could actually use our little API to find report 3533. And there it is. An audio sighting. So cool. Also in Athens. Actually, that was probably in our previous result. So there's that. Yeah, there it is. It was the next one right here, 3533. Cool. This is totally working. Okay, so that works pretty well. This little snugget of code is taking care of things. And all this code will be up on GitHub. So don't worry if you're looking at it and saying, how do I type all this stuff? You don't have to. So we can find by county and state. Let's do full text search, shall we? I want to create in server.js and I'm going to just copy this again here. App.get sightings containing text. And we pass in request.params text here. And so this is the find containing. So we'll add a method called find containing to our sightings data. And this is actually an easy one. He says. Pass in the text here. And looking at my cheater code, just to make sure that I'm not lying to everyone here, I'm going to copy and paste this very sophisticated and complicated code to show you how that we can call this. And there we go. It turns out that if you do a query, then you can just pass in the text and it will look for all the fields that are indexed as text when we create our index. It'll look at all of those and just give you things that match it. Now, this will do nothing for us right now because we haven't updated our index. So we need to update our index to have the fields that we want to do text-based searching on. So I want to do that on the title. So we just say field name, comma, text. I want to do that on the observed. That'd be the eyewitness account. And I want to do that on the location details. Location details are, the details will say, off State Route 33 at the intersection of blah, 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 that kind of stuff. 3 miles down the road, turn left at the Big Rock. So I'm going to make all of these text fields. And so if I stop and restart this service, now it's going to build an index where it can do full text search with stemming and all the full text search capabilities on title, observed, and location details. And so let's go into our little thing. Our URL, we set it up, as you might remember, is sightings/containing/ whatever text we want to look for. So let's do sightings/containing. And let's do Walmart. Okay, so it's blowing up on me. Sightings data is not defined because of copy pasta. Let me be an example to you of the dangers of copy pasta. And that's not working because it jumped to the HTTPS option. There we go. So we actually have 5 Bigfoot sightings with the word Walmart in them. This was approximately 5 miles east of Pratt Walmart on the south side of the road, crossing the dirt road. Let's look for some other words. Let's look for trailer. A lot of people are camping with trailers. We got 135 responses with trailer. We've returned the first 100. Look at 66 here. I was driving down the highway in a tractor trailer rig about 3:30 a.m. Yeah, okay. This was in El Paso County, Colorado. So we're able to search for things. Let's look for trailer park. 36 in the word trailer park. This all started when we left. Wow, that's quite a wall of text, isn't it? So we're able to search by text. That was actually really easy compared to county and state. It was very simple. We've got one more way that I want to search this, and it's by latitude and longitude and with a radius. So I want to do geographical searches. So I'm going to create a find near. And you might remember that we have a especially configured over here in Redis Insight. If we look, we put the longitude and latitude in a specific format as a location. When we build our index, we can tell it that's a geo location, that field is. And then we can search it using latitude and longitude, all the things that Redis geosets do. And we can give it a latitude and longitude and say, give us, all the Bigfoot sightings that are within 50 miles of Athens, Ohio. So let's do that. So I'm going to go ahead again and copy and paste. And I've got 2 versions of this function here because I think this is kind of fun. Because I've got the freedom units version right there, miles, and I have the other units version, the kilometers, that their metric stuff. And we want both of those. And I missed a curly brace here. No problem. There we go. So you can say sightings near latitude, longitude, within radius, and you specify their miles or kilometers. And all we're doing is we're going to call sighting data .find near and sighting data .find near with different arguments. That's all it does. And we just pass in miles versus kilometers here. And we take latitude and longitude and the radius. So let's create our find near method in our sightings data. Find by ID, find by state, find containing, and async find near. And we got the latitude, the longitude, the radius, or the within. We'll call it the radius. And then we have our units, whether it's miles or kilometers. And just for reference, I'm going to look at my cheaty code over here. And we shouldn't really need too much here. It's going to be return, await, and we're going to call this.find again. And here we're going to pass in at location, because that's the the field we're going to look at. And if we're going to do a latitude longitude search, we put it in square brackets. And then we specify the longitude first. Then we specify the latitude. Then we specify the radius. And then we specify the units. So this is saying find records in find hashes where the location contains a longitude and latitude that is within the radius that is within the radius of this longitude and latitude in miles or in kilometers. And you can do meters and feet as well. And that should just work. Let's I've said that like every time, haven't I? But let's go ahead and try that. Let's do sightings near and latitude and longitude. I believe this is Columbus, Ohio. So we will go with Columbus, Ohio. I know I said Athens, but I live in Columbus. And it gets me 0 Bigfoot sightings within Columbus, Ohio. I know that's not correct. There are several nearby. Oh, and that's because the reason it didn't work is because, and this is important, if you don't update your schema, you can't search on a thing, right? So we need to update our schema to tell it that location is a geofield. So let's do location geo. There we go. Now if I stop and start the server, it will destroy and rebuild that index for the umpteenth time. And now if I go out here and reload this, we get 28 Bigfoot sightings within 50-mile radius of Columbus, Ohio. If I replace that with kilometers, it drops to 9 because, as it turns out, kilometers are smaller than miles. And so now we can search for Bigfoot sightings pretty much anywhere. If we wanted to go to Null Island, that'd be 00. I mean, obviously there aren't any Bigfoot sightings at Null Island, right? We get nothing. But we could say within, say, 50,000 kilometers, and that should return all 4,500. That doesn't return them all, but it returns a lot, 3,659 of them. I think that's the number that actually have locations. And we could put it pretty much anywhere. Let's find Athens, Ohio. We've been picking on Athens, but it is prime Bigfoot country down there in southeastern Ohio. No, Wikipedia. We want Wikipedia, and we want to get the location. Oh, and of course it's in minutes and seconds. So we'll do 39 and 82, and that'll be good enough. So we'll say 39 and negative 82 within 10 miles. So 2 Bigfoot sightings. These are actually Gallia County and Jackson County in West Virginia. Actually, I've been looking at land in Gallia County. So, but yeah, so there we go. Obviously, you can create much more sophisticated queries. We could actually create a query where we say we want in this state, in this county, containing this text. And we just could create more and more of these. Let's say find by state containing. And so we'll do state, and we'll do text. And all we're going to do is pass in text here. And then at state is that. And then we should be able to we'll copy the state one. And we'll add containing one text. Find by state containing the state quest.parameters.text. And let's stop and start that. And we'll see if my little decision to call an audible here was ill-informed or not. State Ohio containing let's do footprint. That didn't return anything. Let's see if we got any errors here. Okay, let's do river. That is not returning a result either. I may have a mistake in what I'm doing here, because surely there are Bigfoot sightings containing the word river. Yeah, 699 of them. Let's pick one with a known state. We'll do California. We'll see if I've got a mistake or not. Containing the word river. There we go. So I just wasn't hitting on a common word in the state of Ohio. So here we have that California sighting. So I did not make a mistake. I was safe in calling that audible. So anyhow, so that's a fun little application that's a little data service we built to expose Redis using RediSearch and Express. I plan on doing 2 more of these where I replace the Express piece here with GraphQL, which I think will be very cool. I'm going to use Apollo GraphQL, and I'm going to do another one where I'm going to expose this using gRPC. So thanks for sticking around and watching. All this code will be up on GitHub, and in the description below, there'll be links, so go check that out. And let me know how it goes. If you have any questions, feel free to hit me up on social media. I'm always on Twitter. And you can also join us on Discord at Redis Labs, or Redis, at discord.gg/Redis. Again, that link will be below. I'm always on the server. You can ask me questions there. And let me know how it goes. Also, if you like this video, of course, do the obligatory like and subscribe and follow and ring the bell and all those things that will help you find Bigfoot and the next video in this series. So thanks a lot and have a good one.